total distance traveled by the particle in the first 4 seconds. To answer this question, you need to sketch the quadratic function for the velocity for the function v and the time. So let's sketch. This one is 8 meters when t0, and we have the minimum velocity here, which is -1 here. This is 3, right? And we have the 2 here, we have the 4 here. Okay, so let's focus the graph. So we are going to find this area which is positive. This area positive from 0 to 2. Okay, from the 2 to 4, we will have the area which is negative. Alright, for the area which is negative will be this part. Okay, so we have two portions. One is positive, one is negative. Now let's focus to the graph. Let me make it bigger, the graph. Okay, I'm going to sketch a graph like this. So for this part, from 0 to, this is positive, this is 8. So this side, the area is 0 to 2 is positive. We call as, let's call as A1. Alright, this is A1, area number 1. Integrate 0 to 2 here, 0 to 2 for the velocity function t squared minus 60 plus 8 dt. Okay, that will be positive. And for this part, this part from 2 to 4, this part, the area will be negative. Alright, the area is always positive, but the integration value will be negative. So we need to modulus the answer later on. So now let's focus to the A1 first. We're going to do A1. Later we do the A2. Alright, we want the magnitude of the area, right? So for the A1, we integrate, we will have t cubed over 3, right? Then 60 squared over 2, so be 3t squared plus 8. Don't forget there is a t from the time 0 to 2. So let's substitute carefully for A1. Is 2 cube is 8 over 3 minus 3 times 2 squared, which is 4 plus 8 times 2, right? So we substitute, then we solve it. Okay, we have minus 12 plus 16. So we have the A1 is 8 over 3 plus 4, right? So will be 20 over 3 meter. So this area, this distance, area means distance, is 20 over 3 meter, is a positive value for area 1. And then for area 2, we have to integrate from 2 to 4 for this part, this area. So let's integrate here, my space, integrate t squared minus 60 plus 8 dt from 2 to 4. So if we integrate, we'll get the same like just now, plus 8t, and we will substitute from 2 to 4, we will substitute 4 power 3, and then 3 times 4 squared plus 8 times 4, and then minus, in fact we can use the answer just now. For the 1, 2 is 2, 3 over 3 minus 3 times 2 squared plus 8 times 2, 8 times 2, right? So is 64 over 3 minus 48 plus 32, and we have to minus the integration just now. Is we have integration value just now for the 2 power 3 minus 3 times 2 square plus 8 times 2, right? This value we got already just now, which is actually 20 over 3, right? You can use back. Okay, so now we just focus. This one is minus 16 minus 20 over 3. So we expect the answer to be negative. So here we have 64 minus 20, so 44 over 3 minus 16 will be 48 over 3. So we will get the answer negative 4 over 3, but we need to modulus the answer, right, to make it positive, because this is something to do with the area. So the area is 4 over 3 meter, right? So we write the area is 4 over 3 meter for the down part. So this is the area that we're going to add on. So negative 4 over 3, we will consider the magnitude 4 over 3. So the total area is A1, which is these two meter square, 24 over 3. So the total area, right? Total area is 20. Our answer is 24 over 3 is 20 over 3 plus 4 over 3. 20 over 3 plus the modulus negative 4 over 3. So we make it positive. So we have 24 over 3. So the answer is equivalent to 8 meters square. So this is the area, and the area represents the total distance traveled by a particle in the first 4 seconds is 8 meters square. And for the part C, we have to integrate the velocity function to get the displacement. So the time should be from 0 to 2 and 2 to 4. So we will integrate. If you know how to integrate, you will have 1 mark. After that, you substitute the time from 0 to 2 and from 2 to 4. The displacement will be negative. So because we want the distance, we must use a modulus, right? So the answer is 8 meters. So that's the answer for part C.